Welcome all. Thank you for your interest in teaching handwriting. It is becoming increasingly clear that motor learning for handwriting offers far more potential for language skill development than many people realize. Handwriting has been in the curriculum closet for decades. That apathy stems from several issues, not the least of which is the need for more time to teach reading. We believe that a lack of handwriting fluency is contributing to the reading problem, and that the strategy behind handwriting lessons is a major factor. We will address one key issue today, a teaching strategy widely used for handwriting lessons in primary grades. One of the most common activities is to have a child trace a model with a pencil and then practice by making multiple copies, usually on the pages of a workbook designed for that strategy. Because of our focus upon teaching movement, Peterson handwriting specialists have always discouraged that practice. Instead, we suggest tracing the movement models in our pupil books with the pointer finger. To prepare for this presentation, we used a sophisticated computer program from NeuroScript software to capture information that will illustrate graphically why tracing with a pencil or crayon is not a good practice activity for handwriting lessons. In fact, I think you will clearly see that trace and copy practice may well be harmful. Thanks to apathy, research aimed at a demonstration of connections between motor learning for handwriting and skill development for reading are not easy to find. But these two studies from totally different fields strongly suggest that more science could now bring startling connections to light. In 1988, Babcock and Freed demonstrated that learned handwriting patterns did indeed play a role in the decoding process. Almost a decade later, Shadmere and Holcomb used PET scans to record changes in the brain that were stimulated by a motor learning challenge. This study, organized by Dr. Rose, is available for download from the information directory page on the Peterson website. He has tried hard to get his study published, but editors reject it. They say nobody cares about handwriting anymore. Ironic, isn't it? This reading study is rejected because it also involves handwriting. For this study, teachers in kindergarten and grade 1 collected fluency data and correlated it with the regular reading assessments. The study is currently being repeated in many classrooms to gather data from a much larger sample. The data collected so far clearly indicates a connection. In fact, it indicates that a certain level of letter writing fluency is necessary for reading skills to emerge. Thanks to Dr. Toolings and his team at NeuroScript software, we were able to capture and create charts that will illustrate the difference between writing movement, tracing movement, and finger tracing movement. This chart created in Movilizer shows the trace created when I wrote the word on a tablet. The program measures many things as it captures the movements. One of the measures is velocity. Let's take a closer look. Toolings calls it ballistic movement. The blue crosses are presented at the point of peak velocity of a fluent automatic movement. This movement is called the primary substroke. In this version of the chart, I removed the red 0 markers so that we can focus on the primary substrokes. The stroke movements leading to a blue cross are pre-programmed, guided by the muscle memory. Our goal for handwriting lessons is to create the muscle memory program to enable fluency. The blue crosses are in some ways an indication of a goal selected prior to the movement execution. The movements toward those goals is pre-programmed in the muscle memory. Note that these movements in this cursive sample control size, slant, and spacing for legibility, as well as primary control of the shape produced. The chart at the left shows the movement captured as I traced an image of the word with the pen. The chart at the right is the one produced by writing the word. Movilizer was set to allow 15 seconds for recording. Note that I was not able to trace the entire word within the 15-second limit. Let's take a closer look at the tracing chart. I think you will be able to see why I couldn't finish when tracing. First, note the number of red stop points, 0 velocity, and their locations. I think you will agree that I should be better at tracing than a child. Now note all of the blue crosses. Think of those as marking all of the places chosen as goals for a movement. Let's eliminate the red stop points. Please keep in mind that I have pretty decent fine motor skills as compared to an elementary student who is trying to learn cursive. And I've written the word thousands of times over 60 years. The act of guiding the pen along these lines of the image is obviously very different from the act of writing the word. Our language travels from left to right. For cursive, the lateral movements of the pen control legibility factors. Let's take a look at the chart showing lateral movement velocity against time. Time is shown in seconds along the horizontal scale. Velocity is shown on the vertical scale. The graph at the left shows the tracing movement. Writing movement is shown on the chart at the right. The writing graph shows completion in about 6 seconds. Note the relatively smooth changes in velocity illustrated by the peaks and valleys of the graph. A closer look will help. The graph at the top shows the writing sample. The one at the bottom is the tracing sample. Note in the top graph that velocity increases and decreases smoothly over time. Note the erratic fluctuations in velocity shown in all of those up and down peaks on the bottom graph. Let's take a closer look at the fluent writing graph. These charts both show the writing movement. On the top is the chart of the trace. The bottom chart shows the writing movement velocity over time. I've placed arrows connecting the two graphs to associate points marked. Red arrows connect the stop points. Blue arrows connect primary substroke peaks. Purple arrows connect points where primary substroke and stop points match. I think that you can see the movement is being guided by a pretty clear recording in the muscle memory. Now let's take a closer look at the graphs produced by tracing an image of the word. These two charts show the tracing movement. I started to connect the graphs as on the last slide, but the number of arrows needed created such a mess you couldn't see the charts. Instead, I decided to just highlight the primary substroke peaks with small orange arrows on the velocity graph. Note first the number of red stop points, more than needed. Then look at the number and location of the blue crosses highlighted by the orange arrows on the velocity graphs. If I were trying to learn how to write this word, that is, get the guidance information into my muscle memory to automate it, this graph indicates a pretty messy recording will be made. Now consider that I then practice this movement by writing the word several times over using this stored jumble of information. Peterson strongly advises against tracing models with the pencil. We recommend that pupils trace the model with the pointer finger instead. Let's take a look at graphs created by finger tracing. Both charts here show the finger trace movement. The trace at the top and the velocity over time at the bottom. Note the consistent matching of stop points and primary substrokes. Note the smooth velocity changes. Nice, clean information for the recording in muscle memory. If I now practice writing the word a few times using this stored information, I should be practicing pretty good movement. The objective of handwriting instruction is to get the information into the motor system that will allow automatic processing when the student is focused upon what he or she wants to say. But let's compare on one page finger tracing, and tracing with the pencil. Trace chart at the top, pencil trace at the bottom. This comparison makes it really obvious which activity is providing the best information for the muscle memory. Remember the old saying, garbage in, garbage out? Considering the movement information presented here today, it's pretty clear that the value of our simple pupil book is huge. They are designed to make it easy and efficient to get the best possible information into the muscle memory by finger tracing the movement models. The color rhythm movement models provide eye training as well, helping the child to learn how to look ahead to goals for fluent movement. There's another point shown here. Note the timeline on the trace graph, 15 seconds. And remember that I did not complete the whole word in the time allotted. Now note the timeline on the finger trace at the top. 7 seconds, give or take a nanosecond. If the goal for handwriting lessons is fluency, the choice is pretty clear. Could you be looking at one reason the publishers of trace and copy workbooks don't mention fluency as a goal? Given what you have just seen, is it any wonder so few of our students figure out a way to write fluently and legibly? Independent copy practice does not teach a child how to move. A few might figure out a way to get the boring activity finished quickly. Perhaps this presentation also explains why so many teachers in grades 4 to 6 feel they don't have time to teach handwriting. Their experience shows that time spent practicing in those handwriting workbooks made no real difference on homework and book reports. I don't have time really means the time is better spent on other things because practice doesn't help. Thank you all very much for your time and for your interest in helping to improve handwriting skills. Please visit our website for more information, and don't hesitate to contact us when questions arise. Live support is available via the Internet. Simply email a request or question. A web meeting can be arranged in a few minutes. Thanks again. Bye for now.